Hello, this video is going to go through the A-Level Computer Science, Unit 1, Computer Systems, 2020 paper. Question 1. A hotel uses a computer system to keep track of room bookings. The hotel staff are able to query a database to discover which rooms are booked or which rooms are free. The hotel's computer network uses a client-server model. Describe what is meant by the term client-server in this context. Okay, so we've got two types of networks. We've got client-server and we've got a peer-to-peer. The main feature of a client-server is that the network has a server that the clients connect to. So we can write that down. The network has a server and clients connect to. Okay, moving on from that, we can say that the server would normally store all of the data and provide services such as email, maybe store files. And it's a 3-mark question, so we need to put another point on there. And then we really need to apply it to the scenario. So we could say it can maybe have the database stored on the server, the hotel, so we need to apply it to the scenario. And you could say so that staff machines can access the room booking details. Give 2 advantages of a client server compared to a peer-to-peer. So we need 2 advantages. So we could say, first of all, the key thing a lot of people would always say is that it's easier to manage users because all the users generally log in. Easier to manage the different users. And we could also talk about the fact that there's only one point of failure. So if you think about like a star network, it's not technically a star network, but if one device goes down, if any device goes down other than the server, the network will keep running. So if any of the clients go down, the network will still run. It will only go down if the server goes down. Part B, explain the purpose of a network switch. So a lot of people will get switches and routers combined. So the whole purpose of a switch is they connect devices together to form, and you can say not to form a LAN, you can say this forms a LAN. Okay, and you can say that it transfers data. And when we talk about data in terms of networks, we can say packets between the devices on the network. And you could also say that when we say transfers, we could go into a bit more detail. We could say sends and receives. Okay, so we get into a bit more detail on that. One of the key differences is that between a router and a switch is that a switch operates using the MAC address. So you can say the switch transfers data by using the MAC address in the packet header. Good. Part D. The hotel stores data about rooms, customers, and bookings in a database. Each customer can book multiple rooms, and each room can be booked multiple times. Draw an entity relationship diagram for this database. Okay, so we've got the database and it consists of 3 different types of information: rooms, customers and bookings. So that's going to be our, they're going to be our entities. So first of all, we are going to have rooms, then we're going to have customers, and the last one that we're going to have is bookings. Now let's go back to the question. Each customer can book multiple rooms. So that means one customer can have many rooms, but that doesn't quite make sense. And each customer has multiple rooms, and each room can be booked multiple times. So really, I think a customer's going to make a booking and a room can be booked. So everything's going to connect together through the booking. So what I'm going to do, I'm just going to draw the lines to explain it there. Now in the question it mentions multiple several times. So we need to figure out where the manys are, because they're not all going to be one-to-one. So each customer can book multiple rooms. So that means each customer, if you think about it logically, each customer can have multiple bookings. So it's going to be many on here. And each room can be booked multiple times. So that means the rooms are going to have multiple bookings as well. Like so. Define what is meant by the term foreign key, giving one example of where a foreign key would be used in the hotel booking system. So first of all, we have to define what is meant by foreign key. So I always think of it as a primary key from another table. Okay, and you can say it's used in a second table just to be a bit clearer. Okay, and we can explain that it's there to link the tables together. Okay, we need to give an example now. So if we go to here, so we can say that the bookings table is going to have the foreign keys customer, presumably customer ID, and room ID. We say the booking table is going to have the foreign keys, and we can say, because we don't know for sure it's going to be customer ID, but we can suggest that. We say from the customer table, and I'm going to put customer ID in brackets, and rooms table there. Part 3. Describe 2 different ways that hashing could be used in this database. So the different uses of hashing, first of all, there's security, the so-called security. And the second way that it could be used is for direct access. Now, this is a 4-mark question, so clearly we need to do more than just identify the actual method itself. We need to explain it. So let's relate it to the scenario again. So we could say passwords may be stored in the hotel database. We can explain hashing them means that that passwords can be compared when a user logs in, but it can't be read if the account is if someone accesses the account with unauthorized access. So the can be compared. Let's specify the hashed password compared to a login password, a password entered in cannot be read. So we can say this protects password if someone accesses it without authorization. Okay, and for direct access, so we can say the memory address of where data is stored will be related to the value of the data. Good. And then we can move on to say this means that access times will be quicker. Because the database will not need to be so extensively searched. We can say database / memory. The hotel booking database enforces referential integrity. Explain what is meant by the term referential integrity and how this could be potentially broken. Okay, so referential integrity, that's basically that all of the tables are linked in such a way that when one record is deleted or changed, all of the other associated records in the other tables are deleted or changed. And that's to promote consistency of data. So we can say that we can explain that referential integrity is used to promote consistency of data. And explain that it's across multiple tables using foreign keys. So then we can explain a bit more about when a record is deleted or changed, that it will be deleted or changed in the associated tables. Okay. An example of how it could be broken. So we could say, for example, if a customer, let's keep it related to the scenario, if a customer is deleted from the customer table, then their booking will be deleted from the booking table. Data is deleted or changed. Example is customer table and will be deleted from the booking table. And we could just explain, otherwise the booking table would point to a foreign key that doesn't exist. A supermarket uses an object-oriented approach to organise items that it offers for sale. Part of the class definition for item for sale class is shown below. We've got a class called item for sale with 3 public attributes: item name, price, and discount. The discount attribute represents a percentage discount on the price. The discount can be between 0 and 50 inclusive. All items for sale initially have a discount value of 0. Write the constructor method for item for sale class. So we're going to write this using the pseudocode structure that is in the specification. So what we're going to do is we're going to make a public procedure, and we can give it any name that we want. However, a lot of the time OCR give their constructors the name new, so I'm going to call it new. Do an open and close bracket. We're going to just indent in. Now we've got three attributes. We've got item name, we have price, and we have discount. Now discount, as it says in the question, discount is set to 0. We don't have a value for item name or price. We haven't got anything to set it to, so logic would kind of dictate that actually those they'd be taken in as parameters. So I'm going to do name and item price. Remember, we can't have the same name for the attribute and the parameter, so that's why I'm doing item price. So I'm going to say item name equals name and price equals item price. There, so they are completely different, and that's that one done. Part 2. Write a line of code to create an object of object type item for sale called mushy peas that has a name of mushy peas and a price of 89 pence. So what we're going to do is we're going to use that that constructor that we just created called new, and we're going to save it in a variable called mushy peas. So let's do mushy peas equals, and then what we're going to do is we're going to call new, and we're going to say that it's the method new from item for sale. And now what we have to do is we have to put in our parameters. So our first parameter is name, and the name is mushy peas. And the next parameter is the price, and price is just going to be a real, so we're just going to do 0.89. I put a speech mark on there. I shouldn't have a speech mark because, like I just said, it's a real. And I can close that bracket, and that's that question done. Part 3. Write the calculate price method, which applies the percentage discount to the price and returns the new value. Okay, so one of the key things in this question is, well, we're gonna create a method which returns the new price. So what we need to be aware of is it says it returns it. So actually, so do you see before we did a procedure? This time we're not going to do a procedure, we're going to do a function. We know that it's a function and not a procedure because it returns. Okay, so we're going to do a procedure called calculate price. Okay, and in this what we need to do is we need to create a variable which is going to be our price, so we can call it new price. So the new price is going to be, and then we're going to do some maths to calculate it. So it's going to be the price, the current price, and we're going to just subtract. We can do the original price times the discount divided by 100. Okay, and that should give it to us, and that'll be quite straightforward. Now, the other thing that we haven't done is that we need to make sure, now that we've calculated it, we need to make sure that we actually return it, so that's quite important. So we're going to just say return new price. Okay, that's the key thing, and that makes it a function. Part B. The supermarket has previously had issues with discounts being set as values above 50. Explain how encapsulation could be applied to item for sale class to stop this problem from occurring. You are not expected to write any code in your answer to this question. So we're explaining how encapsulation can be used. So encapsulation is the whole concept that attributes can only be changed by using methods, and that would avoid things like errors such as the discount being set too high. So if we just have a quick look at the different methods that we have. Now, item name and price are both set by the, even down here is a lot clearer, item name and price are both set by the parameters that we put in. So the only one that could be made into, that could use encapsulation would be discount. So first of all, we have to say that the discount attribute would be made set to private. Okay. And next what we're going to do is we're going to explain that we would make a method to set the discount. So it could even be set discount. Good. And within that method, we could have a restriction which doesn't allow it to be set to over 50%. And we could even use the word validation. Discount being set to more than 50. Part C. Some items in the supermarket are only available through home delivery. These items are the same as items for sale, with the following exceptions. The supermarket also stores the location of the stock. The percentage discount allowed is up to 75% rather than the standard 50%. Explain how inheritance can be used to implement in the above requirements. Okay, so it's basically how can inheritance be used for these items which are for home delivery only. So first of all, we have to create a second class. Create a new class. And I'm going to suggest a name, for example, home delivery. And we say that's going to inherit the attributes and methods from items for sale. Attributes and methods from items for sale. Okay, so we've done that. We need to say that in the constructor, we also need to add in location of the stock. In the constructor, new, there will need to be an attribute to store the location of stock. For example, location, let's say. Okay, and then once we've done that, we're going to have to change the what did we call it? The calculate price method. So we need to create a new version of calculate price. Which will override the other. Override the previous version. Okay. And this one will allow the when it's written, it will allow the discount to be 75 rather than 50. Finished. Question 3. Convert the denary number minus 119 to an 8-bit number with 2's complement representation. So what we're going to do is we're going to write 119 as a positive number, then we're going to use 1's complement to invert it. We do a lot of working out for this, so I'm going to do it on an Excel worksheet. You could always do it on a piece of paper, and then you would write your final answer in. So the number we're going to be working with is 119. And what we're going to do is we're going to draw up our table. Remember, when you do 2's complement, the most significant bit is always inverted. So instead of having 128, it's going to be minus 128. 16, 8, 4, 2, and 1. So minus 128 doesn't go into 119, so that's fine. Then we've got 64. So what we're going to do is 64 does go into 119. Then we need to figure out our remainder. So we're going to do 119 minus 64, which gives us 55. 32, let's change that to 55. 32 goes into 55, so that's going to give us a remainder of 23. 16 goes into 23, so that should have been 23. 16 goes into 23, so if we subtract that, it's going to give us 7. Change that to 7. Okay, 8 doesn't go into 7, 4 does, and that'll give us a remainder of 3. 2 goes into 3, giving us a remainder of 1, and 1 goes into it. Okay, so what we have here is 119 written in binary. So what we now need to do is we need to do 1's complement. And what we do for that is we invert all of the bits, so 0s becomes 1s and 1s become 0s. And we just add 1, so we're going to put 1 there, and we're going to just add 1. 0 plus 1 gives you 1, and we've got nothing else to do, so we can just copy all of these, because there's no carry. And what we have here is 119 written in 2's complement. So that's our answer. Next question is asking us, let's put that down. Okay, so the next question is saying, convert the unsigned binary number to hexadecimal. So we've got this number, we need to write it in hexadecimal. So the easiest way is to split it. So I'm going to go back to my worksheet and I'm going to split my number into 2 halves. So it's 1101. I've got, sorry, 1, 2, 3. Okay, so it's a 3-bit and it's a 7-bit number, so it's a bit more complicated. So let's write the number out first. 1101 101. So what we're going to do is we need to split it into 4 bits, and what we'll do is we'll start from the right hand side and we go 1, 2, 3, 4, and that's how we split it, like so. So we've got 2 numbers there. Let's just double check that. Yeah, 1101 and 110. So now what we could do is we're going to just figure out what the value is. I'm just going to write the weighting on just to make it a bit clearer. 8, 1, 2, 4. So we've got a 3-bit and a 4-bit number. So here we've got 12, 13, and here we've got 6. Okay, 6 in hexadecimal would be 6, and then we've got 13, which would be the equivalent of, A, D. Then we put the numbers together, which gives us 60. So our answer would be 60. Convert the denary number 171 into hexadecimal. So what we'll do is we'll just use binary as our middle man for this. So if we do 171 into hexadecimal, 171 into binary first of all. So we're going to use the same method we used earlier. Okay, and we've got, it doesn't specify if it's 2's complement or not. So we'll just presume not for the time being. So we've got 171 and 128 goes into that, giving us a remainder of 43. 64 does not go into 43. 32 would go into 43, giving us a remainder of 11. 16 doesn't go into 11. 8 does, giving us a remainder of 3. 4 doesn't go into 3. 2 goes into 3, giving a remainder of 1. 1 goes into 1. So we've got a number now written here in binary. Now what we need to do is we need to convert it into hexadecimal using the same method we used here. So what I'm going to do is I'm going to just take my number and split it, like so. Okay, so we've got, let's take this off, 1, 0, 1, 1. So we've got 8 plus 2 plus 1 gives us 11. 11 being B. And here we've got 8 plus 2 gives us 10. And 10 is A. So our answer would be A, B. convert the hexadecimal number A6 to binary. So we're going to do the same thing in reverse. So we've got A and 6. We need to represent them in binary. So A would be 10, 6 would be 6. The way we write 10 in binary, we use the same method. So let's draw up our table. So 10 would be 8 goes into 10. So it'll be a 1, giving us a remainder of 2. 4 doesn't go into 2. 2 goes into 2, giving us a remainder of 0. So the next one's going to be 0. And then we'll do the exact same thing again for 6. 8, 4, 2, 1. 8 doesn't go into 6. 4 goes into 6, giving us a remainder of 2. Got 2 there. And 0. So here is our answer. So part B. Show how the denary value minus 9.125 can be represented in normalized floating point format using 8 bits for the mantissa and 4 bits for the exponent, both in 2's complement. So what we're going to do is we're going to take the same kind of method. The only difference is that we have to then represent it with a mantissa and a 4-bit exponent. Everything's going to have 2's complement. So we'll break it down. So first of all, let's write the number 9.125, and then we're going to 1's complement it to make it a negative number. So we're going to go 9.125. Okay, because it's such a small number, we don't need to have that many bits, so we can always go up to, let's just say we're going to start off with 4 bits for the positive. So that will be, let's just go a bit higher. Let's do minus 16, got 8, 4, 2, 1. And because we're going into decimals, if you look, normally with doubles we go to the left, but if you look at it from the angle of going to the right, it halves each time. So half of 1 is going to be 0.5, half that's going to be, it's going to be 0.25, and so on. So if we start with, and let's put in a decimal point as well. Okay, so we don't want to use the minus 16. 8 goes into 9.125, so it's going to be a 1, and that's going to take it down to 1.125. Okay. 4 doesn't go into that, 2 doesn't, 1 does, which is going to take it down to 0.125. Okay, now we're going to do the decimals. So in terms of the decimals, we're going to do, we've got 0.5 there, but we're looking for minus 0.125. So 0.5 is actually significantly bigger, so we don't need to worry about that so much. So we're going to do that as a 0. And 0.25 is also bigger. It looks like I need to go even smaller, so what I'm going to do is I'm just going to get 0.25 and I'm going to divide that by 2 again, and that will give us 0.125, which is going to be a 1, which clears all of this. Okay, so what I've got here is the number 9.125, but I need that in negative, so I'm going to now 1's complement it, which is where I inverse and add 1. So I'm going to inverse first of all. Okay, now what I'm going to do is going to add 1. 1 plus 1 is 0, and I'm going to carry over all 1. 0 plus 1 gives me 1. I don't need to carry anything over, so now it's ultimately everything plus 0, which means it's going to be the same. So here I've got minus 9.125. So now what I need to do is I need to get it to 8 bits. How many have I got here? 1, 2, 3, 4, 5, 6, 7, 8. Good, I'm just going to double check the question. Yep, 8 bits for the mantissa. So I've actually got my mantissa here. Now I need to figure out what my exponent is. My exponent is how many places over the decimal point needs to go. So it needs to move over 1, 2, 3, 4 places, and it needs to be a 4-bit number. So if I do, that's 8, 4, 2, 1, quite straightforward. So it's going to be a 0, for the -8, a 1 for the 4, and 0s for the rest. So my final answer will be, and let's just check the way they put the question around. So it's mantissa and then the exponent. So my mantissa is 1, 0, 1, 1, 0, 1, 1, 0. That's just this number without the decimal point. And my exponent, I'll leave a bit of a gap and do my exponent, 0, 1, 0, 0. And that's my overall answer. And obviously you'd want to get all of your working out on there as well. Show the result of applying an XOR mask to, and you've got a series of numbers, to the byte so and so. So all we're going to do is we're going to apply the XOR mask to them. So we've got the mask down here, and this is our byte. And it's quite straightforward. All we need to do is XOR numbers together. XOR works by, if the numbers are opposite, it gives a positive number. If they're the same, it will give a negative. So opposites, same, opposites, opposites, same, opposites, and the same. So that's our number expressed, once we've had the XOR mask applied. Part 2, describe a mask that can be applied to an 8-bit number to ensure that the most significant bit is always set to 1 and all other bits remain unchanged. So basically what we're trying to do is we're trying to figure out this line, and when we apply this line, our mask, it should give an answer where the most significant bit, the bit to the left, at what we would call the beginning, is set to 1. So what we need a mask which is a way to guarantee always giving a 1. So if we look, we need to first of all figure out what kind of a gate we're going to have. So we could have AND, XOR, or not. Okay, so let's figure out which of these it would be. So and for an AND, you need both of them to be positive. So for example, if the byte was 0 and you've got an AND, it's going to give you a 0. So it can't be an AND because we need the most significant to be 1. XOR, if they're the same, so if you've got a 1 and a 1, it's going to give you a 0. So it can't be that. Or so if you've got a 0 and a 1, that would give you a 1. If you've got a 0 and a 0, it won't, but you could always fix that. So if with an OR, as long as you've got a 1 in that position, it's going to output a 1. So as long as there's a 1, it's going to output a 1. So I'm pretty sure that's the one. A not will just invert it. It just gives you the opposite. So it's not going to be a not because, for example, if you've got a 1 there in the actual byte, it's going to change it to a 0. So we know that it's going to be an OR. So when we do it with an OR, we know the most significant bit is going to have a 1 applied to it because that means that it's not going to change. The others we're not really so fussed about changing. We just want to make sure that the most significant bit is always set to 1. So we can do that by setting it to 1 because anything ordered with a 1 is going to give a 1. And the other bits should remain unchanged. So by setting the rest of the bits in our mask to 0, it's going to mean that they're not changed. So what would happen is if you now OR any kind of a byte with this number here, it's going to leave the most significant bit is going to be forced to be a 1. Everything else will not be changed. Question 4. Complete the Carnot map below for the Boolean expression. Then we've got a Boolean expression. Right, so what we need to do is we need to complete this table. It's just filling it in. So if we look at our table, it consists of 2 sections. They're separated by an OR gate. So the first is not A and not B, and the second is A and not B. So if we look at this table, the top bit, we've got the AB section. Now each of these digits here represent A and B. So the first one is AB, 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 AB. So in the first column it's 0 for A, 0 for B. The next one is 0 for A, 1 for B. Then we've got a 1 for A, 1 for B. Then we've got a 1 for A and a 0 for B. So obviously it's we're working in terms of binary. So not A would be the equivalent of a 0. and not B would be the equivalent of 0. So what we're looking for is 0, 0 on AB. Oh, sorry, and likewise down the side we've got the same for C. So we've got not C and not D. We've got a 0 for C and a 1 for D, likewise. So, but we're just focused on the A and B at the moment. So we would need a 0 for A and a 0 for B, which is this column here. So all of the answers in this column are going to be a 1, because what we're saying is this section here gives us a positive when both of these are set to 0. If we did a second section, for A we're looking for a 1, and for B we're looking for a 0. So that would be this, not this column here, it's the end one. So we've got a 1 for A and a 0 for B. It's quite straightforward because we've only needed to use the A and B. We haven't made use of the C and D. Now what we need to do is we need to simplify it. That's the whole purpose of Kana map. So what we need to do is we need to group it in terms of 1s, 2s, 4s, 8s, 16s. We can't have like a group of 3. It has to be in like binary numbers. So what you can see here is we've got 2 sections. Just missed that bit when I was circling it. We've got 2 sections here of 1s. So we could always submit that, but that's not actually simplifying it. That's going to give us the exact same equation. But because we can work in 8s and it can wrap around, what we could do is we can say we've got 1 section here which wraps around to there, giving us 1 group of 8. So we've got 1 big group there. Now what we need to do is in that 1 big group we need to identify what is the one constant between them. So the C and D's consistently change, so it's nothing to do with C and D. So if we look at them, we're looking at A and B now. So in the first section, A is 0. In the second section, A is 1, so A is not consistent. In the second section, B is 0, and B is 0 in the second section as well. So the thing that's consistent between them is that it's not B, basically. So what we can say is we can simplify it to be not B. Part B, state the purpose of a D-type flip-flop circuit. So a D-type flip-flop circuit is quite straightforward. It stores data, or stores a value, which is 1 bit, and it stores it when the clock is, when the clock goes. Okay, part 2. Describe the inputs and outputs used by a D-type flip-flop circuit, explaining how the inputs are used to control the outputs. So we'll start with the inputs. So you've got the inputs of the data going in. So you've got the data going in, you've got the clock, and the outputs are is the data. Okay, so what we need to now explain is how they are changed, how they control the output. So we can explain that the output represents the input, but it is only changed on the upside of the clock. Okay, so we might want to explain that a bit more. So we might want to say, give some kind of an example or something. So we could say that if the input changes, the output will not change. Until the up phase of the clock. And to just demonstrate it for you, so let's say for example we've got our data here and we've got a clock. What happens is it only changes when the clock is going up. So if I just get a different color quickly, so the up phases would be here, because that's when it goes up. It's going down here, so we ignore that. It goes up here, it's going down here, and it goes up here. So what would happen is our output, we're going to mimic this, but we're only going to update it when we go to the output. So we start off low, it's going to start off low, and now it goes up, but it's still low, so we're going to stay low all the way over to here. And look, at on the up edge it's still low, so we stay low, go over to here, and it's now currently up, so we're going to go up like so. You wouldn't need to draw that diagram. You could if it helps to explain it a bit better. I don't know if you'd get marks for that. Question 6. Two people play a counting game. The rules of the game are as follows. The first player starts at 1. Each player may choose 1, 2 or 3 numbers on their turn, and the numbers must be in ascending order. Players take it in turns to choose. The player who chooses 15 loses the game. For example, if the player chooses 3 numbers, 1, 2, 3, then the second player could choose 1 number, 4, 2 numbers, 4, 5, or 3 numbers, 4, 5, 6. The first player then takes another go. Write an algorithm using pseudocode that allows 2 players to play this game. The algorithm should alternate between player 1 and 2, ask the player how many numbers they would like to choose, ensure that this is between 1 and 3, display the numbers that the players has chosen, display a suitable message to say which player has won once the number 15 has been displayed. So we basically have a game, 2 people play, they take it in turns, they choose between 1 and 3 numbers, and they go up in ascending order. So I could say I want 3 numbers, 1, 2, 3, the next person could say they want 2, 4, 5, then I could go again, I could say I want 3, which will be 6, 7, 8, and whoever hits 15 loses. So I think one of the key things in this game is that the player who chooses 15 loses. It's a repetitive game, so actually that means we've got some level of iteration. So we're going to have, well, it's going to run while the number's less than 15. So what I'm going to do is going to have a variable called number, and I'm going to say number, I'm going to set it to 0. We might have to change that to 1 later, we'll see. I'm just going to say while number does not equals 15. I think that's what I want to go with. Let's actually, because they might say they want 3 numbers, so it might go, they might say, for example, 14, 15, 16, because that's going to end on 16, then we're going to end up higher. So what I might say, while it's less than or equal to 15. So that's what we're going to start. So the first thing we need to do is alternate between the different players. Okay, so I'm just thinking, do we want to set the player in or out of the loop? Let's set it initially out, because we're going to start with player 1. So I'm going to set it to player equals 1. Okay, then within here, and what we can do is further down, we'll change it. So let's say we're at the end of the player's go, so it's going to be kind of low down. We're going to say, we need to just swap it, don't we? So we'll say if player equals 1, then what we're going to do, we're going to say player equals 2, and then we need to do the opposite. So we say else. So if it's player 2, we're going to say player equals 1. Okay, so we've got that one done, alternating between them. Ask the player how many numbers they would like to choose, ensuring that this is between 1 and 3. So that sounds quite straightforward. So we could say choice equals how many numbers would you like to choose? I need to make that an input. Okay, so I've asked them how many they'd like to choose, and what I'm going to do now, so I've asked them, but if you look, it says ensuring that it's between 1 and 3, so I need some level of validation. Maybe I also need to indicate which player it is, so what I could do, I could say player, and I can concatenate on the player number. Say how many numbers would you like to choose, and then what we could do is we could have some kind of validation there. So we could say if choice is greater than or equal to 1 and less than or equal to 3. Okay, so we've got an answer from them, so what do we need to do? Okay, we need to display the numbers that they've chosen. So what we want to do is, I suppose, because it's going to increment, we need to print out each number, and it's going to go over and over. It's going to be a loop. It's going to happen a set number of times, so it's going to be a count control, so it's going to be a for loop. So it'll be 4, and how many times do we need to go? We need to go the number of times that's listed in or the number of choices they've chosen. So I'm just going to call my variable x in range, and the range is going to be choice. So all that's going to do is it's going to run this as many times as they've chosen. Okay, so now what do I need to do? So I need to display the numbers that they've chosen. So what I need to do is I need to get on number. I need to add on. I need to add 1 each time, and it's going to run as many times as they've chosen. So I'm going to add. So say I choose 3. The first time it's going to add 1, then it's going to print it. Then it's going to add another 1, print it, add another 1, and print it. So I'm going to do number equals number plus 1, and then I'm going to print number. Okay, so it displays the numbers that the player has chosen. Okay, and then that's going to go, so it's going to go through that 1, 2, or 3 times. Once it's done that, it's going to say if the player, then it's going to swap the player over, and this is going to run as long as it's less than 15, and we've started at 0, which is absolutely fine. Is that right? Yep, and it's going to go until we get to 15, and that's done. So now what we need to do is we need to say who's won. So if you hit 15, you've lost, and then what happens is it flips to the other player. So the other player is going to be the one that wins. So whoever it's set to player will have won. So once our loop has finished, we can declare the winner, and it's going to be whoever player is set to. So we can say print player, and then we're going to concatenate on the player number has won. Question 7. The table below shows the Little Man computer instruction set. You've got a series of mnemonics, you've got some gaps as well. Part A, complete the table above to show the missing mnemonics and instructions. So basically you should have all of these memorized really. So STA, that's just store. And we can go into a bit more detail, and we can say in a given memory address or location. Branch always is BRA. BRZ, branch if 0. BRP, branch if positive. And end program is halt, HLT. Part B, write a program using Little Man computer instruction set that will allow a user to input 2 numbers and then output the larger of the two numbers, the program should loop continuously. Okay, so two numbers go in and it outputs the larger one, and it just needs to keep going over and over. So if that's going to happen, what we need to do is we need to indicate where the start is, because we're going to have to loop back. First I'm going to label the first line start, and we're going to begin there. So we need to input a number, IMP, and the way this is going to work is that we're just going to subtract the numbers from each other, and then if you have a positive number, that means that the second number was bigger than the first, and we're going to just work on that basis. So we're going to input a number and we're going to store it in first, then we're going to input a second number and store it in second. Now what we need to remember is that when you input a number, it goes into the accumulator, which is where the most recent data entry goes to. So the number we're currently working with is the second one. That's what's in there. So what we're going to do is we're going to sub from the second one, we're going to subtract first. Okay, and now basically what we're going to say is that if we have a positive number, then the second one is biggest. So what we need to do is we need to say if it's positive. There is no if command, but we do have BRP, branch if positive. So if it's positive, we're going to branch to another line, and let's call this line, what could we call it? We've got first already, so let's call it first n, n for number. Okay, and this is going to get pushed down further most probably, but we'll say first n. So if it's the first number that, we're saying the first number is bigger, aren't we? Sorry. Yeah, we're saying the first number is, no, sorry, we're saying the first number is, yeah, the first number's bigger. So what we're going to do is we're going to load LDA first and output it. And then that's our program done. Because we're done, we need to branch, we need to loop back to the top. We're always going to do this, so it's going to be BRA. And we're going to branch always to start. That's that bit done. One thing I've forgotten to do is in Little Man Computer, whenever you create a variable or label an area of memory, you have to label it further at the bottom. So what I'm going to do is I'm going to say first that and second that, and they always go at the bottom. Now what I need to do is say, I've subtracted the first from the second one, and it's come up as a negative number. So that means, sorry, I've got my numbers the wrong way around, haven't I? So if it comes up as a negative number, that actually means that the second number is bigger, so I'm going to load second. Okay, so now I'm saying and that should be on the same line. There we go. So what I'm doing is I'm saying that in this case, actually my first number is bigger, so I need to load first, and then I need to output it, and then I'm going to loop back, so BRA to start. So I've done it in those different sections. So I've got a section here for at the bottom for my variables. I've got a section here called first n, which outputs the second number. I've got my section here which loads the first number and outputs it. Question 9. Imogen buys a desktop computer. It comes with an operating system installed. Describe 2 ways that an operating system could manage physical memory. So this is just managing your RAM, memory management. So the first is paging. And this is when the memory blocks are equal size. And the next is segmentation. And this is when they vary in size dependent on the program. Vary in size. Part 2, explain one benefit of memory management to the user. So memory management, the best thing about it really is multitasking. Okay. It means that more than one program can be run at once. Or can be loaded at least. Part 3, describe how virtual memory allows a user to run programs when physical memory is full. So all we need to do is really explain how virtual memory works with reference to paging. So that's quite straightforward. So first of all, so when physical memory is full, unused pages are moved from the memory to the secondary storage. Okay, and then what we can explain is that the freed up memory can be used to load new programs. And we can also explain that if the program that has been moved to the secondary storage needs to be loaded, then it will be moved back to the physical memory. It will be moved back to the physical storage, to the physical storage, yeah. Part B, operating systems make use of device drivers. Define what is meant by the term device driver. Give one example of a device driver that a home user would need. Okay, so a device driver, it's quite straightforward. It's a term that you should just have memorized. So it's software that enables the computer to communicate with hardware. An example, and basically it's almost anything ending with driver, printer driver. Part C. Operating systems usually come with utility software pre-installed. Give 2 examples of utility software explaining the purpose of both. So utility software is software that is used to maintain the computer. So it's just basically what software do you have to look after your computer. So it's quite straightforward. So we could say the first one we've just been discussing, encryption. And then as a second one, we could put down an easy one to explain is backup. So encryption, we've already written the definition, which is why I've gone for that. It's a 4-mark question. We've got 2 points on there, so we need to put another 2. So we just need to define encryption, which we've done already, which is it scrambles data. This is software that scrambles data and requires a key to unscramble it. When it is scrambled, it is useless. So it will not be useful if it is stolen. Okay, and the next one we've got is backup. Okay, again, really simple one to explain. So backup software makes regular copies of software in case it's lost. Also data. Part D. Imogen installs a compiler for a high-level programming language onto her computer and makes use of an open source IDE. integrated development environment. State what is meant by the term open source software. So quite simple term. Open source means that the source code is freely available to be edited. Part 2. Give one benefit to Imogen of using an open source IDE rather than closed source. So the main benefit of open source, there's two I would say. First of all, that it's free. Second of all, that it can be customized to her needs. So I'm going to go with that one. The IDE be customized to meet her needs. Part E. When Imogen creates programs in a high-level programming language, she uses libraries. Explain what is meant by a library, giving one example of when a library might be used. Okay, so what we need to do first of all is explain what they are. So they are sections of code written by other people that can be imported into a program to give additional functionality. Imported to give additional routines and functionality. Okay, good. And the question says, explain what is meant by that, giving one example. So now what we need to do is we need to give an example. So we could say, for example, in Python, importing random to allow random number generation, or importing, it says one example, so we'll just stop there. Part 2, describe one advantage of using library files one advantage of the use of library files to programmers. So what is the advantage to a programmer? So first of all, it saves time because the routines are already written, so they do not need to be written by the programmer. Okay, good. Describe one disadvantage of using library files. So what's it going to be a disadvantage? So when you use a library file, what's going to happen is that when you compile your program, the library will get compiled as well. And imagine you've just used it for one routine, one command, but you've got 1,000 on there. It's going to increase your program, so your program size. It may increase the compiled program size because the library may include lots of unused routines which will be compiled when the main program is compiled. Part 4, explain how linkers are used during the compilation process. So, for example, if you have created a program and you've imported a library, you've linked it to a library, how are linkers going to be used? So obviously linkers link the main program to the library. They can either compile them into the final executable file, or they might just point to the external libraries.